talking about line types. I want to pull this up. So can everybody see what this says up here? It's kind of small. I made it just bigger now. ANSI standards. Do you remember this? American National Standard Institute. And this is talking about what the rules are in terms of drawings. So if you click on this, let's take a look. Does this make sense to you? So this is called precedence of lines. Which lines are the most important? Does it make sense to you that visible lines or object lines are the most important? They represent the edges you can see, right? The next is hidden lines. Hidden lines take next precedent, along with cutting plane lines. And the reason why is hidden lines represent edges that are on your part that you just can't see from that view. But they still represent the edges that a machine shop is going to try to cut. I mean, when you design something as an engineer, you have an option as an engineer. I'm talking mechanical right now. You either give the machinist the package and the material, or you tell them what material to buy and you give them the package. Typically, when you give them the material, the job just goes a little quicker. It just means that you had to spend extra time because you had to go get the material. So you get the material, you give the machinist the package, and then they're looking at the package and taking this and cutting away everything to give you the part that you want. Okay? So edges are the most important. Thinking ahead, do you think that you dimension to the visible lines or to hidden lines? Visible lines. You always dimension to visible lines. So let's say you're dimensioning the front view, and there's an edge that's communicating a hidden view. Where do you dimension to that edge? Let me ask the question again. If you're doing some dimensioning in the front view, and there's an edge that you want to dimension to, but it's a hidden line, you don't dimension there. Where do you dimension it?
Top of the side.
In one of the other views. In the horizontal view or the profile view. You always dimension to visible edges, not to hidden lines. Okay? Why? It's an ANSI standard. It was decided that that was important. So this is showing precedence aligned. Visible lines come first, then hidden lines, then center lines. Okay, then I have a whole bunch of ANSI standards here. It talks about, when I draw hidden lines, do I go to the edge or not go to the edge? If I have hidden lines, do they meet? Do they not meet? So these are all, when I have center lines, does the center line go outside the space? Do hidden lines, hidden lines go over the center line because hidden lines are more important. So all these ANSI standards are things that I want you to look at. And the way you're going to communicate that you looked at it is I just want to slow down, this thing goes. So on class 3, this is where the ANSI standards are under the class notes, but on the homework, there's an ANSI standard rule homework. Use the information included in the precedent lines class notes, and please do the following. Determine approximately 10 ANSI standards. I just want you to look at all those sheets and identify 10, there's more than 10, identify 10 ANSI standards and write them up. Okay? Let's go back to the module.
Do you have to use lettering for that?
Why don't you type it?
Okay.
And then you don't have to. Good question, Roland. Okay. ANSI standards. We're going to look at more multi-view. Let's look at drafting supplies. Okay? So it's not written up here. So who has purchased the drafting supplies so far? Good, a lot of you. Notice that it says one of the homeworks for today is to purchase your drafting supplies. And let's see, we're going to put it here. Well, by Wednesday's kind of crazy to ask you to do it within 2 days, so I'm going to put it on here. Let's do isometric homework and purchase drafting supplies. So that means it's due class 5. So let's go back up here. few last five. Okay, so, so let's take a look at, who again has the supplies? Why don't you pull them out so the people next to you can see what's included in it?
Haven't opened anything. Oh, really? Yeah.
Literally, like, I didn't even get to use this. It's fresh. I'm so mad about that.
Okay, so it should include, a 30, 60, 90 triangle small.
Special. Not just shape, special.
That is
It should include a protractor. It should include an erasing shield. I don't know if you've heard of erasing shields before, and maybe you saw this and you didn't even know what it was for. It's really awesome. Remember before when I was taking an eraser and I was erasing a whole bunch of stuff? Everybody up here. I was erasing a whole bunch of stuff, and then in the end I had to go back and redraw some lines I erased. What erasing shield allows you to do is, let's say I have this, and I realize that, shoot, this, can you zoom in? This right here is what I want to erase, nothing else. If I go there with this, I'm probably going to erase other things. So I take my erasing shield, and I say, oh, right here is what I want to erase. And I see, oh, it's a little bit more right here. Isn't it cool? Really cool.
super cool.
Super cool. That's an erasing shield.
That's
So protractor, 30, 60, 90 triangle, small, an erasing shield. Should have a divider. A divider looks like a compass, but it has 2 points on it, 2 metal points. Right, a compass has a pencil on one side. It's a divider, and up here there's no screw. There's nothing locking it. So it allows you to move this back and forth. Remember I showed you last week, like transferring dimensions? It's really great, Donovan?
It does come with pencil ends for it, so you can make it into like a makeshift.
Really?
Yeah,
Comes
it
with
comes
pencil?
with lead and another.
Okay, but it's definitely not screwed, good.
Yeah.
Okay, great, good, you could use it as a, it's hard to use it as a compass though if it's not fixed, you know? Okay, and then you should have an engineering triangular scale, a little different than this. I think the one I ordered was a little longer. Yeah, this is awesome. One of the students had this last semester, and I was really jealous. So that's why I put it in here, and look, it's nice, really nice. Okay, an engineering scale. A lot of times the engineering scales we use are huge, and during the semester we could use these. I have a whole bunch for you. But what I really wanted you to do is I wanted you to get supplies that are small enough that you can have it with you all the time. And you don't always want to be carrying this around. And that's why the 30, 60, 90 triangle is small, this is small, everything's, you know, compact. Okay, what else is in there? Is there an eraser in there?
Yes.
Yeah, a good one, a Stadler?
General.
All right, well, hopefully it's really good. It's just all right? Yeah, I'm gonna have to try it. Next time I'll make sure you get a Stadler. The only other thing that I wanted in the kit, and I think I told you, is, is the rolling ruler. Where did I put it? This is what I wanted in the kit, a 6-inch one, again, because it's small and compact. The reason why the kit bags are so big is when they ordered it, they couldn't find a 6-inch one, and they put in a 12-inch one. And I told her to pull it out of the bag. I don't want you to have to walk around with a 12-inch rolling ruler. And then I had the price decreased, so that's why you should not have paid $39. You should have paid $31. It sounds like Edwin, they made him pay 39 anyway, so, okay.
Take yours.
Rowan, so you're gonna go back. Well, you have an option. The other option is, so what I did, because they said they couldn't find 6 inches, I found them and I bought them. And I have to go look to see what the price was. But I think it's like $7 or so plus tax, so it might be the same price, but let me look at the price. But you should buy these, it's your option, you don't have to buy one if you don't want to. But I would suggest buying it, so I'll find out how much it is. It's about the same price, so you guys who paid $39, if you want, because you probably don't want to deal with the bookstore, just take this for free and then you call yourself even, and don't worry about the department laying out this money. And then you don't have to deal with the bookstore. But if you want to go back, you can. So I'll look this up during the next break to see how much this is, okay? So that's what I would suggest, you have the little kit that they have and then buy this from the department. Okay? Any questions on this? So scales we haven't used yet. Oh, let me give this back to you. Scales you haven't used yet. Protractor, you may have used the protractor because on the paper that's on that, at the beginning of the syllabus part of the Canvas page, remember what is the degrees that an isometric is up? What degrees? 30. And what about oblique? 45. So I don't know, probably you didn't need to use this yet because I gave you that paper with the angles on it for that first homework assignment, but we'll be using these soon. This is great as a straight edge too. Oh, let me tell you, don't use a scale as a straight edge, okay? Don't use it. It takes off all the little lines on here at times, and plus you just look like a new engineer. Because this is for measuring. It is not for drawing lines, it's for measuring. You want to measure something, you would put a dot and another dot, and then you take your straight edge and you draw the line. So don't ever, don't use this as a straight edge. Okay?
Using your scale straight.
Okay, all right. And the reason that it's designed like this is so it can give you 6 different types of scales, and we'll be looking at scales soon. Okay, protractor, so this is all the pieces that you should have. This could get kinked, so be careful. Maybe set it in there between the protractor. And this, and an eraser, and don't poke yourself with the, but you have it looks like you have a case for yours, so. Okay. All right, I'm going to go back to okay. So class notes, drafting supplies, you have to get it by a week from today. If you get it by Wednesday, awesome. ANSI standards we looked at, and you have a homework assignment on that. We're going to look a little bit more at multi-view drawings, and I have a little activity that we're going to work on, and then there's some homework down here. And there's practice problems, I pointed this out to you before, so not only are you getting your homework assignment, you're doing your homework assignment, but if you feel like you need more practice, then use the practice problems. You're really the only one who could tell whether you need help or not. After I look at these quizzes today and I record them, I'll see who needs extra practice. Okay, so what I'd like to do is let's look at the point and plane activity. And actually, sure enough, I didn't check the packet I gave you, see if this is in the packet. I don't think it is, so I'm going to go make a copy of it. No, it's not, because it would be right on the top of that. Okay, so let me look at something else first. That will do, while I go photocopy this activity.
Next one says tutorials.
Say it again? Yeah, tutorial. Thanks. Okay, so I just want to show you some more slides from, well, actually, let's go back and just make sure we look at the slides from last week. And what it would be really nice is for you to check in with the person next to you to make sure that you're both or all in your group, making sure that everybody's moving along on this stuff because it is new to some people. Okay, so we looked initially at there's 6 different sides, but there's how many planes? 3 planes, front and back, left side and right side, top and bottom, 3 planes. This one, normally how many orthographic views do you need to communicate apart? 3. And the standard is front, top, and profile. Which profile?
Right.
Right is usually the standard, right? So when we look at a pictorial, when we look at an isometric, we know this is the front, this is the right side, and this is the top. How come, take a look at this. Can you picture what this looks like?
Not clear.
Okay, so let's see. From the top, we have 2 circles here, right? Notice the center lines, there's a crosshair. The center line goes outside this circle, but the center line goes outside that because this center communicates not only this circle, but also this semicircle. What do you think this is? If you look at the front view, what do you see? What do you think this communicates to us? A hole. It's a hole. Is it same thing here? Another hole. Okay, let's look at the front. There's a piece that's going to protrude out, right? And then this is still an arc, and that's why it goes outside. And then you see here, there's some hidden lines. So what do you think's happening here? A hole too, just a hole drilled from the front rather than the top. In this case, this is what it is. You only need two drawings, a top and a front. How come?
Pretty symmetrical part.
It's symmetric part. Like look at your water bottles, right, or cans. They're symmetric. The bottle here, you only need 2. You need a top and a front, because the front and the side are almost the same, In this case, the side is a little different, but it's still symmetric, so you only need 2. So typically, standard is 3, but sometimes you only need 2. Andrew, you had asked, right? You had asked, well, what happens if drawing only the 3 views is not enough? That's when you introduce a sectional view, because there's something going inside that you need to communicate. So you do a sectional view, and there's also called an auxiliary view. So you never do, if you do 3, and if you need more than 3, you do a sectional view or auxiliary. You don't know what an auxiliary is yet, that's fine, just know the word. You don't draw the back, or the bottom, or the left side, because it's telling you the same information. So it's 3 plus some other fancy ones. And both line type homeworks, the line type homework you had, or the one we did in class last week, and then the quiz, notice they put a sectional in there, right? They put a cutting plane line and a sectional. And the one we did in class last week, there was a viewing plane and a cutting plane line. So then you have their hand up, Griffin? No? Oh, okay. Peter?
Answer that question.
Got it, okay. All right, so, and this one in this case is an isometric. You see, we'll look at this page again when we do, on Wednesday, we're gonna start drawing in 3D. Okay, so this was class 2, multi-view drawing notes. And now I'm going back to class 3, which is today's class, to look at some of the drawings. So why is it called an orthographic view? Because your eye is perpendicular to the plane, right? Here's my object. I have this document camera here. And here's my eye, and my eye is perpendicular to this plane. And if I'm looking at it this way, these are all orthographic views. It just happens the orthographic view that I'm doing is from the front and the right side and from the top. So here, what kind of 3D is this? Isometric, right? Isometric? I want to hear everybody. Isometric. And now I'm looking at the front view. I'm putting this plane that's parallel to the frontal plane, and I'm looking at it perpendicular. This part right here is inclined, right? But from the front, it doesn't look inclined. It just looks shortened. In fact, I guess, let me roll this down a little bit. what it's, as if, like, think about math. This is the hypotenuse. If I carried this line out and I carried this line up, these would be the two sides that are perpendicular to form the hypotenuse. When you look at it from the front, you're looking at this height here. And when you look at it from the top, you're looking at the depth. And what actually is there is the hypotenuse. Does that make sense if I put it in mathematical terms? Okay, let's look at another slide. Same kind of thing, I have my box here. I have this object, I'm looking at it, perpendicular, perpendicular, perpendicular. I think you get the idea of this, it's just you need more practice. This we already saw, this we saw. Excuse me. Remember the front view is width by height, and height is transferred from the front to the side view, and the width is transferred from the front to the top view. And then if you take these lines up, take this point, go perpendicular, not perpendicular, 45 degrees, and when you hit that line, you come over, and now you're transferring the depth. Talk to the person next to you about that. How do you transfer depth? It's a little confusing.
You get it from
That's why computers go right. Like, I understand what you're saying. Those are the hard words.
Okay, so this is the total width of the part, right? Everybody, and this is the total height of the part. This, at this corner right here, you're transferring the distance up, and then you could transfer this depth over. Okay, let's look at another page. This is interesting. I think this, now it's getting a little more, I'm getting a little more detailed. What's going on here? There's no line here, but let's look at the next picture. You see the difference between the two 3Ds? Look at that. You see the difference? This plane and this is tangent. This curve is tangent to this. Where here, it's not. So there's a line here. But in this one, there's no line. I mean, this is kind of detail work. But see, there's no line here, where on this one, there would be some line, would be a line. Okay? Okay, so what I'm gonna have you do, that's 3. While I go make a photocopy for this point plane activity. Here's the homework assignment.